Okay, in this tutorial I'm going to help you understand how the characteristics of a river change as you move from where it begins, which is known as the source, shown up here in the mountains in this diagram, to where it ends, where it joins a lake or another river or the sea at a location called its mouth. Now when we talk about the characteristics of a river, we are thinking about all of the things that make up that river. So we might be talking about how wide it is from one bank of the river to the other, how deep it is in terms of its depth. We might talk about how fast it's traveling, or a more technical word for that would be its velocity. So how does that change? If we were to lean into the river and pull out a rock, would we pull out a little rock or a big rock? Would that rock be round or would that rock be very angular? So those are all what we would term its characteristics, and how do they change from the beginning of its journey high in the mountains up here down to where it joins the sea. So let's just explore these ideas in a little bit more depth. So here we can see a diagram that shows you a few aspects of our river. First of all, we can see that it is high above sea level here, whereas here it is generally at sea level, so at the mouth. Now, because it's high above sea level, there's going to be a huge amount of gravitational pull on the water as gravity tries to pull it back down to sea level. So the gravitational pull is going to be very high here in the mountains. And by the time it gets to sea level, it's going to be very low. Okay? Now that's quite an important concept to understand, because the higher the gravitational pull, the greater there is going to be this thing called vertical erosion. Now vertical erosion is to do with the idea that the force in nature, in this case the river, is eroding downwards into the landscape. So it's like pushing a knife into a cake, and there's a huge amount of energy pushing that knife into the cake. And the idea would be that in the mountains, that amount of energy is really high. So the river's eating downwards into the landscape, whereas down here, where it's about to join the sea, there's very little vertical erosion because it's near sea level now. And because of that, you're going to get the opposite, which is called horizontal erosion. Now that's where, instead of it trying to eat down into the landscape, or cut down into the cake, if we imagine it that way, it's actually starting to erode side to side, like sweeping a knife back and forward across a cake, the top of a cake. Or in this case, the river eroding into its river banks rather than to its river base. We're going to come back to this idea of vertical erosion and horizontal erosion in later tutorials and lessons. Right, now we've understood that kind of first basic concept of what's going on in our river, let's think about some other key changes. Well, we can see that the gradient is really steep in our river here. So it'd be flowing, the river's flowing over a steep landscape, whereas here it's very horizontal because we're on a much flatter landscape. So we've got a steep gradient and we've got a gentle to flat gradient down here. Okay, and that's the next key factor, because that obviously affects the velocity of the river, because water flowing over a steep slope is going to flow fast, and over a gentle slope down here, it's going to flow quite slow. A bit like you riding a bike. You ride a bike down a steep slope, you're going to go really fast. You ride on a flat slope, you're going to go quite slow. Okay? However, there are other things going on in a river that we need to understand. And this brings me to the first main sort of task in this topic, which is Bradshaw's model. Okay? Now, Bradshaw was a geographer who explored rivers, and his key idea was he was trying to explain how rivers changed from the mountains, or what we call upstream, to their downstream stage. Now, if you've never spent much time next to a river, you will if you've ever been near a river in the mountains, you'll notice it's a tiny little trickle of water, a little burn, we might call it in Scotland, small stream. And by the time you get to downstream in places like Perth, where the River Tay passes through, or Glasgow, where the Clyde passes through, or the Forth at Edinburgh, you'll have noticed a huge amount of changes from that tiny little trickle of water in the mountains to that downstream. So what he was doing is he was trying to use this diagram we can see here to describe those changes. And that is your first key task. So what are you going to want to describe? Well, the first thing is, what does his model actually tell us? So his model breaks down a river into what we call its main characteristics. We can see these here. So first thing it describes are the river's characteristics. Okay. So for example, he talks about the discharge of a river. And the discharge of a river is the volume of water passing a certain point every second. Okay? And we actually measure that, and the unit we measure that is called cumex, which is cubic, that's the CU, meters, that's the M, per second. So if you were standing next to a river, and you looked at that river, and you drew an invisible line from one bank of the river to the other, and you then measured the actual volume of water that moved past the point you were standing every single second, you would be able to measure its discharge. Okay? So if we just have a look at some of his other ones, that's probably one of the harder ones to understand. If we just look at some of the simpler ones, we've then got another characteristic. It's width. So how wide is the river? That's a fairly obvious thing to be able to measure. You just do a tape measure to measure that. The depth. So if you stood in a river, how would the depth be changing? The speed, the velocity. Now the load quantity, that's just to do with the actual amount of stuff the river's carrying. Now we call the stuff a river carries sediment, and sediment can vary from a big boulder that is rolling along the bottom of the river to a tiny speck of sand or silt, as it's known, that's actually floating in the river, so small you can barely see it. All of that added together would be counted as sediment. A big rock would be one bit of sediment, a tiny little granule of sand would also be one bit of sediment. So how much is it actually carrying? Then the average size of the stuff being carried in a river. How rough is the riverbed? You can normally see how rough a riverbed is. If it's got lots of rapids, then the riverbed's probably quite rough, and if there's no rapids, it's quite smooth. What's the slope of the river? Its hydraulic gradient is how, this is a complex one by the way, how efficient the river is at moving water. So when you slide down a flume in a swimming pool, for example, you've got water flowing down that flume with you, and the plastic on which you're shooting down is very smooth, and therefore you move relatively efficiently down that flume. Whereas if there were lots of little bumps and in that flume along the way, and maybe instead of being nice smooth plastic, they'd kind of glued lots of little pebbles and rocks. Now, first of all, it's going to hurt you, but also you're going to move down that flume a lot less efficiently than you would do if it was a nice smooth bit of plastic. So that's the kind of the idea of efficiency. How efficient is the river, or is the channel of the river? And the channel, by the way, is the thing the water flows through. How efficient is water at moving through that? And then we can ignore this one, but this is the amount of friction that's actually in the river. And the friction, by the way, is created by the river flowing across rock, which creates friction. And if you're all familiar with the idea of friction, that's where if you rub your two hands together, you generate heat because of friction. Right, so let's just go back to, we've now looked at all the characteristics. So actually the question says, describe what this model's showing us. The very first thing I would say is, it's showing us that the river has lots of different characteristics. And what I would then do is just describe a couple of these characteristics to illustrate what is meant by the idea of characteristic. The second thing it does is it shows how the characteristic changes. So the first one is it shows characteristics. The second factor this diagram shows is how does it change. Now, he does that through showing triangles that get either bigger, like this one. You can see this triangle starts small over here and gets really wide here. Okay, so what that means is he is telling me that this characteristic, discharge, is increasing from upstream to downstream. So discharge is getting larger. So what he's really saying is that the amount of water passing every second when I'm standing next to a tiny wee river up in the mountains, it's going to be tiny. Tiny little amount of water will be flowing past me. By the time I get to the mouth of the river down at Dundee for the River Tay, I'm going to have a huge discharge. Some of them decrease, like these ones down here. So what he's saying here is that the actual average size of a rock in the river gets progressively smaller in size because the triangle starts wider here and gets smaller down here. So that's the second thing he shows. Just to review that. The first thing he shows is the river has a whole bunch of characteristics. The second thing he shows is whether they increase or whether they decrease as you move from the upstream to the downstream. And the final thing is how big the triangle is. And he does, for example, discharge is a massive triangle. And what he means, why he makes this a big triangle, is he's trying to show us that discharge is something that will increase dramatically from the mountains or from the upstream to the downstream, from the mouth of the river. If it's a small triangle like velocity, he's telling me that the increase is actually going to be relatively small, that the river's travelling, by the time it gets to the mouth down here, the river's not travelling much faster than it was when I was in the mountains. And that's the third aspect. The size of the triangle shows you how much change you would expect to see. So answering this question, tell me first of all that the Bradshaw's model breaks a river up into its different characteristics and give me an example of what we mean by river characteristics. Second thing is tell me about the triangles either increasing or decreasing, telling me whether something increases as we move downstream or decreases, and give me an example, or give me a couple of examples, for example, discharge versus load particle size. And then the third thing you need to describe is the size of the triangle. So the triangle either increases dramatically, like discharge here, and load quantity, or a small amount like slope angle and load particle size, because they're small triangles. So key thing is in your describing is not just telling me the model, but actually giving me some examples from the model. So that's the first tutorial that helps you understand how rivers change, and this Bradshaw model, what it tells us about how a river would be expected to change.